Okay, welcome to lecture 3.10.1. So, in lecture 3.10, I gave you some hints for your homework assignment. Occurred to me that maybe I should have given some more hints. And so here's a bonus one. So I had 3.10. It's 3.10.1. A little extra, a few extra hints. The main thing I want you to think about is when you are programming a likelihood function. So this time it's just in Excel. Later you're going to do it in R. And when you do that, there are so many ways to make an error. There are so many ways to make a typo. And if you make a typo, it just ruins everything. And you might not know it. Think of it this way. During the Apollo program, they said that every component had like a 99.99% reliability. Those things were pretty sure. But the problem is, so that's like what, 1 in 10,000 chance that it messes up. Well, the problem is they had something like 100,000 components in the Apollo spacecraft. So 100,000 components, each one has a chance of 1 in 10,000. In expectation, you're going to have 10 that have an error. And you think, like, well, what can he do about that? Well, what they decided is that one, you can do like testing on board. You can have like something where you have some system where you run 100 of these components, and then you find out if there's an error, and if not, you run the next 100. If not, run the next 100. So you can do these things in series to find out if there's an error, and that's one key when you're doing these Excel spreadsheets or these, especially the R programs. Try to break them up into as small as chunk as you can. So if you're writing an R program, first write the program. Make sure that you've inputted the data correctly. Make a little program that inputs the data, and then do these tests to make sure. Do the means and standard deviations of your data, of your independent variables, and make sure that that it looks like you're getting about the right answer. Something similar with your Excel spreadsheet. Try to break these things up into as small a task as you can. And so, for instance, you're going to have a likelihood. So in your homework, what you're going to do is you're going to create these terms: PDD, I think it's DS, PSS. So that's these terms are given a crash. What's the probability that both drivers were drunk? Given a crash, what's the probability exactly one was drunk? PSS, given a crash, probably both were sober. And then you're going to have these terms: Q, I think that's the percent of drunk drivers on the road. And anytime lambda, that is theta S divided by theta D. First, if you've got the PDD, okay, say you've written it by hand on paper what all these terms should equal. Plug one of them into a spreadsheet, say PDD, and with another couple cells have a Q and a lambda, and start trying different values of Q and lambda to make sure that PDD makes sense. So for instance, what if you made that lambda equal to 1, which would say that if you're sober, you're no more likely to if you're drunk, you're no more likely to crash than if you're sober. Okay. If that were true, the probability both are drunk should just be so. Given a crash, that doesn't give you any more information about whether the drivers are drunk or sober than your prior information. So Q would be all you need to know. So if that lambda is 1, Q, and you see a crash, which probably both are drunk, should be something like think of Q times Q, and then do something similar, P times D times S, and then try it where lambda equals 0, and try to think of different ways. Does this make sense? Does this make sense, my values of PDD, PDS, and PSS? Once you've done that, then you can start programming in a likelihood function. And then if try as best you can, just like a little subsample of data where you make up the data, and you think, oh, does this make sense? Like you make it where, suppose you make it all your data. You put in 4 data points and make it so that all the drivers were sober. Okay, and you think, well, if that's true, I think Q is the percent who are drunk, and then start. If you've got a likelihood function, the probability that all 4 cases the drivers are sober, what's the maximum likelihood value of Q? You should experiment around and say something like the value Q equals 0 would be the one that makes the most sense in that case. Make sure that Q equals 0 would maximize that case with just some sample data. Do it again with sample data where all the cases are PDD, and just try to make sure that you've entered these PDD numbers exactly right. Next, you're going to have you're going to take the log of the likelihood. Do it first when you don't take the log. Just plug in your likelihood function. Then do it again where you take the log and make sure you're getting the same answers. So try to break this down into as many steps as possible. So you do one little teeny step, you make sure that's right, do another one, and so on. And that's important for building these likelihood functions. Okay, so that's one little tip, okay? Keep that in mind, not just for this homework, but for all the remainder homeworks in this class. Okay, so that's this little minor segment. I guess you should now watch 3.11. Okay.